Hello again, vacationers. I hope you're enjoying yourselves. It's a balmy 30 degrees out. Might be a high of 40 with a little bit of sunshine today. I'm sure it's nice wherever you're at. But the second part of chapter 9, talking about reflections. Okay, the whole chapter is about transformations, moving things, changing the shape, sometimes not changing the shape. Today we're talking about reflections. So in order to do a reflection, you need something to reflect over. It's called a line of reflection. It's basically like the idea of a mirror. Now, in the first part, the translations, that was the shifts, we talk about what an isometry was. It's a transformation that preserves shape, meaning pre-image and image are going to be congruent. A reflection is an isometry. So, to give you an idea of what reflections can look like, just starting with this triangle, triangle ABC, and I'm going to reflect it over the y-axis. So that moves it over to this point, these A prime, B prime, C primes. So you can see as I move point A around, it changes where point A prime is. Now, you should notice a couple of things. The distance from point A to the line of reflection, that is this segment, it is exactly the same as the distance from the line of reflection to the image point. So those two are congruent and perpendicular. Okay, it doesn't matter which point we talk about. The distance from point B, from the pre-image to that line of reflection, this is a distance of 2. That's the same distance from the line of reflection to the image point and perpendicular. Okay, you can see the same thing is happening with point C prime. That's always going to be true. So now, that's reflecting over the y-axis. Here's a reflection over the x-axis, same idea. If I put a point on the line of reflection, well, the image is right there on the line of reflection. Okay. Other lines of reflections. Let me move this back to where it was. Other common lines of reflections, I should say. Excuse me, I should say. This line, it's the y equals x line. If we reflect over that, same idea. We're going to go perpendicular to that line of reflection. We're going halfway across the diagonal of this box, of this grid. We do the same thing on the other side and going perpendicular. So the same thing happens. From C, we have a slope of 1 for our line, and so we're going to go perpendicular to that. That's a slope of -1. Okay, so we're going to go from C. That's going across the diagonal of 2 boxes. We go across the diagonal of 2 boxes. There's its image, point C. All right, so that's a common reflection, and there's some stuff to that that you'll work with on the worksheet. There we go. And the other common line of reflection is y equals -x. This is a line that has a slope of -1. When we reflect over that, same idea is happening. To go from A, we're going to go perpendicular to that line of reflection. We want to cross 1.5 diagonals. So we got to go 1.5 diagonals to get to its image point. And you can see as we move, as we move point B around, you can see how that is changing, but it's always going to be that reflection. So when you do a reflection, there's 2 things to be conscious of. And like I mentioned in that other picture, the geometry picture, you're always going to go perpendicular to the line of reflection, and you're always going to go an equal distance on the other side of that line of reflection. So if we wanted to reflect over, let's go to the y-axis. All right, you're just going to go 2 units from A to that line of reflection, go 2 units on the other side, A prime. B is 3 units, so we're going to go 3 units onto the other side. There's B prime. C is only 1 unit away, so we go 1 unit onto the other side. There's C prime. Form your triangle. There's its image after being reflected over the y-axis. Now, what you're going to do on the homework is pay attention to the coordinates. When we do certain reflections over the y-axis, the ones I showed you on that last screen, over the y-axis, over the x-axis, over that line y equals x, and over the line y equals negative x. There are rules of the coordinates change in this specific way because you're reflecting over one of those things. So to get those rules, and I'm not going to talk about them now, I want you figuring them out from the worksheet, but to get those rules, pay attention to the coordinates. There's a pattern in these coordinates. Point C was at the point 1, 1. Point C prime is at the point, let me change the color here, is at the point negative 1, 1. Point B is at the point 3, 2. Point B prime is at the point negative 3, 2. Point A is at 2, 4. Point A prime is at negative 2, 4. What's changing to go from the pre-image to the image? What is changing in every single one of these corresponding points? A to A prime, B to B prime, C to C prime. That's the pattern. You should be able to tell me from a generic y equals x, I'm going to get a certain point. And for the y-axis, look at what's changing. The y coordinates stayed exactly the same, but the x coordinates, they're opposite. So negative x, y. This is the rule for a reflection over the y-axis. Okay, we're changing the sign of the x coordinate. That's what I'm talking about, is there's specific rules for those coordinates when you're reflecting over certain lines. Okay, I want you to come up with all those rules. You'll see on my website there is a clean copy of the worksheet that we're going to be doing in class, but make sure you follow the directions on that sheet. You can use your answers, use the answers that are also there to help you along, but try to figure out those patterns from looking at those coordinates, looking at the pattern of the coordinates. I hope you have a wonderful day.